Okay, all right. So today I am recording from home because today's the first day back from spring break. All right. So I think everyone's home today. So, okay. Anyways, so we're starting a brand new unit, okay, today, which is Unit 10, Day 1. And what's Unit 10? We are going to spend the next 2 months, if not a little more, talking about quadratic functions. So we've talked about two types of functions so far, right? So one is we got the linear functions. So that was way back in the fall. And then not too long ago, we were doing exponential functions, right? Where the exponent's an actual letter, right? Instead of a number, right? And then today we're going to do the third thing, okay? And the absolute, probably the most important unit of the year, and maybe the most important unit of math in the middle school level, which is quadratic functions. So we're going to take our time, gonna show you every concept you need to know because as you will see very quickly, you need to know how to do this in high school. Okay, all right, so let's take a look. Okay, and here we are. So I'm very excited to start this unit really for two reasons. One is I mean, I gotta tell you, like, even at this age, I still remember doing this stuff in high school. Like my freshman year in high school, we must have spent like a good 2 months doing this at least, okay, especially back in the day. And so on one end, like, it's something that I'm used to doing. Not a lot of teaching, so most of the work now for me is just figuring out what's the best way to teach this for the next 2 months. And the second thing is, this is a signal that the school year is coming to a close, okay? So a little bit happy and a little bit sad. Okay, so this is really it. All right, even though this thing is gonna take us over 2 months. All right, it's kind of like the beginning of the end, of the school year. So, all right, now polynomials. So for the next 2 days, I'm guessing Thursday, Friday, if I'm remembering this right. For Thursday, Friday, by the way, it would be nice if you write this down. So Unit 10, Day 1, polynomials. Okay, so if you need to press pause, do that. What was I saying? Oh yeah, for the next 2 days, we gotta get the definitions down. Now, I mean, think about that for a second, right? Like every time you guys have had a class, the last 3 years, perhaps regardless of any subject, right? If you're beginning a new unit and the teacher gives you all the vocabularies, that usually takes a day, right? But this tells you just how immense and important this unit is that we're gonna spend 2 days talking about vocabulary, okay? Which never happens. Okay, so I want you to take this slowly and seriously. Okay? Alright. Now, why are we doing this? Okay? And one of the things I want to get through, one of the main ideas I want to get through to all of you is that in high school, you're gonna be doing this stuff. Alright. As a matter of fact, probably 10th grade, if not 11th grade. All right, you're going to be doing these sort of expressions, operation with rational expressions. Okay, so what I'm trying to say then is um, your ability to understand things that are going on in this unit is going to have a direct consequence. Hold on, I got to get some water. So, like I said, a few years ago, I was tutoring a high school student on this stuff. And while I was doing that, it reminded me just how important for an eighth grader or high school student to be able to just turn this, let me show you, turn this to this, or turn this expression here to this. Okay, so this is what we're about to learn is not small step, sizable step into you eventually being able to do stuff like even this. Okay, and I think I showed that to your parents during curriculum night. Maybe not. All right, so don't get too intimidated by this because you really won't be solving any of these until 2 years, at least 2 years from now. But one of the things I do want to emphasize then is Um, this is why I've been, really trying to encourage you guys to do all your homework, this year and try to understand this stuff, despite the circumstances that we find ourselves in. And that's because I'm not thinking about just this year. We got to think about the next 4 years of high school, and more specifically from a math perspective. All right, because this stuff, like once you hit the ground running, all right, you got to be able to do this stuff. All right, by the time you're a 10th or 11th grader. So, all right, so that's why I'm giving you such a long, pep talk with this. All right, anyways, so here we are. Now, we're gonna spend 2 days on these definitions, but more realistically, I'm gonna show you all the definitions today, and then tomorrow we're gonna spend a lot of time practicing. Okay, so that's what this really is. Now, how much time have I used already? Almost 5 minutes. Great. Now, okay, so right off the bat, right, we need to talk about the difference between an equation and an expression. All right, long story short, since you know this already, an equation has an equal sign and an expression doesn't, right? So an expression, there's really nothing to solve. An equation, there's always something to solve. Okay, that's the first thing. Now let me change colors. Variables, right? You all already know what variables are. So a variable, oops, why did I pick this color? So a variable, right, it's just the letters, right? So in this case, the variable is x, That's it, all right? Nothing crazy. It's a letter, right? A constant. What's a constant? It's the number, right? So in this case, this is the constant, right? So a constant is just a number, right? So in 2x plus 5x squared plus 1, the constant is 1, right? Okay? Now, what are like terms? Right? What are terms, first of all? Right? A term, it's a part of a mathematical expression, right? Look here, look to the right side, right? That are separated by a plus sign or a minus sign. See that, right? Plus sign or minus sign, not multiply, not divide. Okay, got that, right? Plus or minus, right? So now, question. So in this example, right, how many terms are there? Yeah, there's 3 terms, right? What about in this example? How many terms are there? Yeah, 3 terms. What about this example? Yep, 4 terms, right? 1, 2, 3, 4. Okay? Right? Now, what's a like term? We talked about this at the very beginning of the year. What's a like term? It's 2 terms. 2 terms. 1, 2. 2 terms that have the same exact variable. X and x, right? With the same exact exponents, right? No exceptions, right? That's what a like term is, right? Okay, all right. Now, what's a monomial? In that case, then, right? It's a one-termed expression. So, like, for example, 2x to the third, right? That's a monomial. One term, nothing else. What's a binomial? Something like this, right? 2 terms. What's a polynomial? Something with many terms. So for example, like this, right? It's got 3 terms. Now, technically, right, even a monomial can be a polynomial, but I won't get into that right now, okay? I'm gonna wait like a few minutes to do that first, all right? Because I just want to use this as a review of everything you've learned so far, all right? Now, polynomial. So this is a focus on what exactly is the definition of a polynomial, because we have to get a little bit more detailed, okay? So this is a polynomial, right? And I'll use the color red. This is not. no variables in the denominator. Okay? So in other words, now, sometimes you don't see it like this, by the way. Sometimes you see it like this. I'll show you. What about this? Okay? Why is that not a polynomial? Yeah, because remember with negative exponents, variables go to the bottom, to the denominator, right? So therefore, not a polynomial, not a polynomial. All right? Now, another thing that's a no-no is you can't have fractional exponents. So for example, you can't have x to the 1/2, you can't have x to the 3/2, anything like that. Okay, because technically a fractional exponent, right, can look something like this. So this, you don't need to know this, but this is the same thing as the square root of x. Okay, so not a polynomial. All right, so what's a polynomial, right? Terms, no fractions, no variables in the denominator, like so, like so. All right, and no fractional exponents. Okay, now that's a 1, right? Okay. By the way, just want to ask you guys this. There is a variable next to this last constant here. Do you guys know what it is? Think about it. Think about what expression of a variable with an exponent will give you something that gives you back 2. So in other words, 2 times what gives you back 2? Times 1, right? What's the expression? What's an expression that can give you back 1? Yeah, x to the 0 power. So technically, if you look at this 2, technically I'm going to write it, I'm going to color code this, okay? I know this is a lot of information. 2, and then in red, it's actually x to the 0, okay? So if someone were to ask you, hey, is 2 itself a polynomial? Technically, yeah, because this is really 2 times x to the 0, which means this is 2 times 1, which means it's 2, right? Same thing. Okay? Again, a lot of information. Now, why I just explained this already, so we're good. Okay? Moving on. Coefficient. All right, I'm out of space already. Coefficient. So, what's a coefficient? Is, let's say you got 2x squared. Should have been, let's see, 2x to the third, okay? So what's the coefficient? It's the number in front of the variable, right? So the coefficient here is 2. So let me give you a quick quiz, right? What's the coefficient for this term right here? Yep, 5. What's the coefficient for this term right here? 3. What's the coefficient for this term right here? 7. What's the coefficient for this term right here? -4, right? Remember the sign comes with. What's the coefficient of this expression down here? -20. All right, got that? Okay, all right. Now we're talking about standard form. Now let me press pause and see what's the best way to present the information. So hold on 1 second. Oops. Okay, so, yep, I remember now. So the example we're going to use for, let me use green. The example that I want to use with you guys for standard form is this. Let me ask you all this. What's the difference between A and B here? Look closely. What's the difference between A and B? All right, if you want to press pause, you can press pause, okay? Yeah, the difference is the arrangement of the terms, right? So notice how here we have 3x to the third plus 5x squared plus 7x. Here I just rearranged it, all right, which many of you do very well to begin with, right? Here I got 5x squared in the front, 3x to the third in the middle, and then still have 7x in the end. That's it. That's the difference, right? So what does that mean? In order for you to put these expressions into standard form, you must find the variable with the highest exponents. Now that's a 1, you know that, right? That's a 1 right here, right? And to find it, once you did that, all right, shouldn't have done that. You have to put them in order, okay? I'll repeat. Hold on 1 second. Again, you look at the exponents of each of the terms, right? So for this term, the exponent is 2. For this term, the exponent is 3. For this term, the exponent is 1, like we mentioned already. And you got to put them in order by the power. So that's why this is not in standard form. So look, this is not standard. All right, but this one, it's in standard. Why? The term with the highest power, right? The highest exponent comes first. The second highest power comes second, and the one with the least power comes third. That's it. That's standard form. Okay? Now, that said, let me show you. Let me see if this is a good time to show you this. You know what? No, because I'm going to keep going. All right, okay. So we checked off standard form. What's a leading term then? Perfect segment. Perfect segue, right? What's a leading term? The one with the highest power, the 3 here in this case, since it has the highest power, that makes this the leading term. All right, it's kind of, I mean, it's not the best analogy. It's like saying who drives the biggest car. Do you understand what I'm saying? Like, if you got the biggest car, then like, you know, I don't know, maybe that makes you a celebrity or something. All right, someone famous. All right, or someone, I don't know, extraordinarily rich, right? Think of it like that. So again, two things. One is standard form means the term with the greatest power comes first, and then followed by the second greatest power, so on and so forth. And after that, what's the leading term? Is the term with the highest exponent, with the highest power. Okay? Now, we checked that off, right? Leading term. Now let's talk leading coefficient. So what's a leading coefficient? Same thing, kind of. Looking at the leading term, what's the coefficient of the leading term? Yeah, it's 3. Okay, so you see, like, I mean, this is kind of crazy when you think about it, just how many terms there are in mathematics. Okay, I gotta cut this short soon, by the way. All right, okay, so that's the leading. So for example, no, not yet. Let's save those for last. Okay, degree. If the leading coefficient is 3, the degree is 3. All right, so that's it. All right, so the degree basically is asking you, hey, go back to your highest exponent, right? Largest exponent, what's the number? So 3, it's a third degree expression. That's how we say it, okay? Again, I know it's a lot of information, I know. Now, that brings us to the last part of the actual lesson for today, which is this. Degree, right? So what does that mean? Linear, all right? This is going to go to 20. I just want to tell you that right now, okay? 20 minutes. All right, linear. So this is a straight line, right? So back in the day, right, y equals to mx plus b, right? Y equals to 2x. In this case, it's actually 2x plus 4, right? That's the actual equation, right? So that's a linear expression or function or equation, okay? The second one that we did probably a month ago now is it's cubic. Oh no, this is exponential. Okay, it's okay. All right, exponential. Okay, so the line looks curved like this, right? The equation always looks like, I don't know what it is, okay? But the exponent is a letter. Lastly, this is quadratic. So what's a quadratic equation? You can see the spelling here, by the way. The quadratic expression is something where x is to the second power, okay? And then so on and so forth, yada yada. Okay, so notice the difference between the three, right? A linear expression, just 2x, 3x, x, anything, right? Exponential, x is in the exponent. And lastly, for quadratic, x is not to the first power, like linear. X is to a different power. Second power, by the way, all right? Quadratic, second power only. So let's come back and finish this off. So what does degree mean? Linear is degree is going to be 1. First degree. Quadratic, the degree is going to be 2. Cubic, what do you think the degree is going to be? Yeah, 3. Okay? Now, let's wrap up today's lesson by talking about everything we've used before. Okay, maybe I'll just do one example or two examples with you guys. Doesn't matter. All right, look. So look at this one, right? How many terms are there? Yep, three terms, right? Um, let's see. What's the follow-up question? Oh, is this a monomial, binomial, or trinomial? Yeah, three terms, right? Trinomial. Okay. Let's see. What else should I ask you? Is this an expression or an equation? Yeah, expression, right? What else do I have to ask? Is this in standard form already? How do you know? Yep, it's in standard form already. Why? The highest power, the term with the highest power is already written in the front. 3, 2, 1. Right? Got that? Right? So now, so since this is in standard form, what's the leading term? Yep. 6x to the third. What's the leading coefficient? 6, right? And what's the degree of this expression? Yep, 3, right? Third degree expression. Got that? Okay. All right. Did I miss anything? I feel like there's so much stuff going on. All right. Okay. All right. What about this next one? All right. Expression or equation? Yep. Expression, right? How many terms are there? There's two. Look, you got to be careful here. You can combine like terms here. Okay. So see how I threw that in, right? Combine like terms. Now I'm just gonna rewrite. I'm just doing what we did, early in the year. Now, since I combine like terms, how many terms are there? Three terms, right? Is that a monomial, binomial, or trinomial? Yep, trinomial, right? Um, what's the degree? Yeah, second degree, right? What's the leading, what's the leading term? Yep, 67x squared, right? What's the leading coefficient? 67, right? What's the degree? Second degree, right? Is this a linear, exponential, or quadratic? Yeah, quadratic function, right? Okay, so I'll leave this for the last thing to do in class and then some practice. Okay, all right, wow, 21, I feel bad. All right, let me sign off here and hopefully, again, you understand most of it. If you don't, I wouldn't worry too much about it right now. Tomorrow, we're going to spend a lot more time practicing. Okay, so thanks for hanging out here and I'll see you guys in class. Okay, all right, bye-bye.
OMG, that was so good.